In this video, we are going to discuss a question maximum sum non-adjacent elements. Okay, so this question starts the beginning of a new approach that we are going to learn in this video. So up until now, we have solved several questions where to find a certain minimum or maximum sum value. We explored several paths, and after exploring all those paths, what we did is we found maximum or minimum as per our requirements. But here we discuss a new approach. The approach is called as greedy approach. What that approach does is that it reduces our runtime significantly. Okay, so it reduces our time complexity. Okay, and how does it do that? It does that by actually eliminating some paths which we found out that it would not give me uh, any optimal solution. So what I mean to say that is that if you already know that some path is not able to give me the required solution, right? So is there any need to explore that path? We already know that that path won't give me the solution. So what is the need of exploring that path? That path does nothing but takes our time. Okay, so greedy does that. Greedy does what? Greedy actually eliminates, actually prevents us from traveling that path and reduces our time, okay, by eliminating those paths. How the elimination actually occurs, how this greedy actually works, this you will get a better understanding when I actually solve the question. Okay, so this question is very important to understand the core base of greedy. So I want everyone to pay their full attention here, and if you actually pay attention, then I think you will enjoy the video. Okay, so let us start and discuss what the question wants you to first. Okay, so basically, as the name suggests, uh, the name is maximum sum non-addition elements. So as the name suggests, it involves some maximum sum, finding maximum sum and non-adjacent elements. Okay, so first of all, let's discuss what non-adjacent elements mean. So what are adjacent elements? This should be obvious, right? In any array, or basically the given input, the elements that occur just after or just previous to that given element are adjacent to the element that we are discussing. For example, let us say we have input like this. So for 11, what are the adjacent elements? This 10 and this 12, right? Same for this 12. What are the adjacent elements? This 13 and this 11. This 10 is not adjacent, okay, for this 12. So that is what I mean to say, is that if I form a certain subset of this set, then I actually form a sum, okay. If I involve this 10, I cannot include this 11, okay. That is I want to what is or that is what I want to you to understand, is that I have to form the sum of elements where no two elements are consecutive, okay. No two elements are adjacent, not consecutive, adjacent, okay. That is uh, that the meaning I have already explained. Okay, so I have to actually form a sum which is the maximum, and in that sum no two adjacent elements have been considered. So one approach would be what, the brute force approach. Out of the blue, that you would think that the brute force approach would be to actually form all such possible subsets where no two adjacent elements have been included and find the maximum sum out of all those subsets and actually print it. But can you imagine how much time would it take? So let us say uh, I have a set of n elements, and since every element has two choices, either it will occur in the set or not. So that means I would have two options for each of those n elements. That is, I would have 2 to the power n possible subsets of those. Okay, so you can only imagine how much time it would take me to take us to actually evaluate these 2 to the power n subsets, right? So this is not a good approach. One another way is it is also basically a brute force approach, but a bit optimized, just a bit optimized. Is that is what I'm going to discuss. Then I'm going to discuss the approach that we are actually going to use. Okay, so first of all, let us take an example. Okay, let us say for n is equal to 5, we have 5 elements. 5 elements are what? Let us say like this. So those are 5, 10, 10 again, 100 and 5 again. Okay, so input is like that. I am going to write these 5 elements on the left, since I am going to make a tree here. Okay, So I want these elements as labels to our tree, such that I can explore all these elements one by one. Okay, right, in this red 5, then I would explore 10, then 10, then 100, and finally I explore, let me give more space here, explore 10. Okay, and we don't need this anymore, let me remove this. Okay, so initially, since before visiting any of the given elements, what would I have initially? I would have an empty set, right? So why am I saying set and set again? Because what we have to do, we basically have to form a set and to calculate its sum, right? Set is what? A collection of elements of these superset that we have been given, right? And out of these superset, we have to select those elements which are not adjacent and they give the maximum sum. Okay, that is why I'm saying set and set again, because eventually we have to form a subset which gives the maximum sum and does not contain any adjacent elements. Okay, so let us start. Initially I have nothing, so I have total sum as 0. Okay, now let us explore the elements one by one. So as I said earlier, each element has two choices. It will either occur in the set or not. So 5 would either occur, that is, it would either come. So let me draw it a bit better. So 5 would either come or not. That means 5 would either occur or not. If 5 occurs in the set, what would the elements I have until now? 5. Okay, so this would give me 5, and if not, this would give me again empty set. Okay, again for 10 I would have two options. 10 will either occur or not occur. So if 10 is included, what would I get? I would get 5 10. And if it is not included, if 10 is not included, I would have just the 5. And if 10 is in, same thing here, 10 can be included, cannot be included. So we have to explore all the possibilities, right? So we do not just explore this one, we have to explore this one also. So here, if 10 gets included, I would get 10, and if not, it would just remain empty. Okay, but we have already been given the question that we cannot include adjacent elements, so this thing is not possible. Why? Because 5 and 10 are adjacent. Okay, so this branch is actually not possible. So one thing that we can take is that if we have already included the current element, or let us say if we have already included the previous element, I cannot include the current element. Okay, so in this case, current element is 10, the previous element was 5, and I have already included 5 in here, so I cannot take 10 in this case. So I only have one option, is to exclude the current element. That is, I exclude the current element. X means exclude and tick means include. Okay, so here x means exclude, that is what I'm going to get. I'm going to get 5 only. Okay, and as I said earlier, uh, when I exclude, I would have again have two options, right? If I exclude, it doesn't mean that I have to include in the next iteration. If I exclude, I would again have two options. I can either include or exclude. So I can either include or exclude. So these two here both options are viable. Okay, now let us move to next step. When we get another 10, now this 10 is not adjacent to this 5, right? So here I excluded earlier. So what I can do is I can actually include here. So a trick for you is that when you mark a cross here, the next would have two branches. When you mark a tick here, the next would have one branch. Okay, so just a little reminder. Okay, when I get a 10 here, what I would do is I would get a set of 5 and 10. When I don't get a 10 here, when I don't include the 10 here, I would just get 5. Okay, same thing here, but here I have already included 10, so this 10 and 10 are adjacent, so I cannot include the 10 again. So this would just give me 10, and this would have with two options, that too I did not include here. So either I would include, this would give me 10, or not, so this would just give me blank. Now I have to make branches here, so I have to move this. uh, just do this properly first. Okay, so I will just move this here, like this. Okay, and just remove this. Now let's proceed. Now I get 100. Okay, so if I get 100, here I have already included, so I don't have the option of including. Here I not included, so I have options of including, not including. Here I did not include, so I have options of including, not including. Here I included, here I included, here not included. See, here included, so I cannot include again. Here I can include and exclude again. Okay, so if I exclude, I would get 5, 10. If I include, in this case, I would get 5 and 100. If I exclude, I will just get 5. If I include here, I get 10 and 110. Okay, no, actually I will get the previous element first, so 10 and 100. Okay, if I don't, I would just get 10. If I don't, I would just get 10. Here, if I don't, if I do include, I will get 100, and here I will get nothing. Okay, and the last last element that we have is, since we have excluded earlier, I can include here, so I would get 5, 10, 10. Here I will get 5, 10 because I cannot include. Here I did not include. Here I can't include because I already included earlier, so I would just get 500 as the final. Here I can include or can exclude. If I include, I would get what, 5, 10. If I don't, I would get what, just 5. Here I cannot include because I have already included earlier, so I would get what, just 10, 100. Here I can do both things, so when I include, I get 10, 10. Let us mark those so it is clear. If I don't include, it will just give me 10 again. Here I have not included, so it is getting a bit messy. Let me just draw it like that. You get the point, right? So it is getting a bit messy. So let me just what can it do? Let me just draw a bit small so I can draw the rest too. So if I include this, for include, I would get 10 and 10. If I don't, I would just get 10. Here again I can include or exclude. So if I do include, I would get what, I would get 10, 10. And if I don't, I would just get 10. And if I, yeah, if I already included here, so I can't include, so I would just get 100, and I can do include or exclude, and I would just get 10 or nothing. So I have formed the whole tree. So now can you see how much time it took me to draw the tree? So just imagine, for elements greater than this, how much time it would actually take you to do so. So this is not a desired process, right? Now let us see the approach that I am going to use to solve the question. That is a greedy approach. How does it actually works? Okay. So what I'm going to do, I'm first discussing the what and how. How will actually solve? Okay. So just do this here, right here. So first of all, I'm going to discuss what and how we are going to do, and the why part I would come back to tree again. Okay, to explain why we actually do that. Now let us start. So the first thing I'm going to do is I'm going to make two variables. Okay, two variables. One would be named include, other would be named exclude. Okay, and since I have taken input for five elements. Okay, so let us start. I would write 10 here, not 10. 5 is our first element, so 5, 10, then 10 again, then 100, and then 10. So last one is 5, right? 5. So I'm going to store each element one by one. So this, and this one is for include, and this one is for exclude. Now let us start by visiting 5 first. Okay, so when I include 5, the total would, what would I get? The include would become 5. When I exclude 5, I would have nothing. So both are initially 0. Both are initially 0. So when I include 5, include becomes 5. When I exclude 5, exclude becomes 0. When I exclude 5, yes, exclude becomes 0. Okay. Now here is the main story part. So at this point, you have to trust me. Okay. Why this is happening, I will explain that later. Just keep up with me. I'm going to write the formula and just draw the conclusions here. Why I explain later on. Okay, now let us start. So when I get 10, since I have already included 5, this means what? I cannot include it. I cannot include 10 here, right? So I cannot include 10 here. This means that I cannot add 10 to 5 here. But can I add 10 to this exclude? Right? In this case, I did not exclude 10. I did not include 5. Okay. So I can add 10 to this 0. That means I would get 10. Okay. And here I have options to either include 0 or 5, because this 5 is what? This 5 is not included in this 10. Basically, this 5 has been excluded. So I can either write 5 or 0. But I would write 5 here. Why I have written 5 here? 5 is the maximum of these two. I've written 5 here. Why we have taken maximum, that I will discuss later on. But just to trust me right now. Okay. Now I get 10 again. I have to include this 10. Can I include this 10 in this 10? I cannot. Why? Because these two are adjacent. But I can include in this 5, right? So I would get 5 plus 10 what? 15. Out of these two, the maximum is 10. Then I get 100. I cannot include in this one, but I can include in this one, right? So I'll get 110. Then the maximum of these and this is 15. I get 5. I cannot include in this one because 105 are adjacent, but I can include in this one because this is exclude. Okay, 15 plus 5 would be what? 20. And this maximum is 110. And when after the final iteration, I would do what? I would find the max of this include and exclude, and this would give me answer. Okay, now I've discussed what and how. This is doing what, and how is what. Exclude is being found by doing maximum of include and exclude, and include is being found by adding the current element plus the previous exclude. So you can clearly see previous exclude was 5, current element is 10, so include becomes 15. The exclude is what? The max of include and exclude. So here exclude is max of 10 and 5, so this would be 10. This is what and how. Now why is this happening? Why are we doing this? Okay, so let us see on the tree right. Now discuss greedy, how it actually works. Okay, so let me write these things again. So what I'm going to do is I'm going to make these labels again. Here I'm going to write include, here I'm going to write exclude, and here are the labels. So this is for 5, this is for 10, this is for 10 again, this is for 100, and finally we get 5. Okay, now let us start. So initially I will include 5, so I'd get 5, and I have excluded 5, so I'll get 0. Okay, now let us start here. So I included 5, so I get 5, exclude 5, so I get nothing, so I write 0 here. Okay, so as you can see, the tree is working along with this thing. Okay, now see here, when I include I get 10, so I would write 10 here. When I exclude, I have two options, 5 and this thing. Which one would I consider? Now if you take the branches above this thing, okay, so here the first exclude, so I would take the branch above this thing, this part, the part above this, and here I get second option, so I would take this part. Let us compare these two parts, so you'll get a pattern of between these two parts. So here we have 5, here we have nothing, here we have 5, 10, here we have 10, here we have 5, here we have 5, here we have 5, 10, here we have only 10, here we have 5, 10, 100, 500, we have only 100, here we have 5, we have nothing, here we have 5, 10, here we have 10, here we have 5, here we have nothing, here we have 500, here we have only 100, here we have 5, 10, here we have only 10, here we have 5, 10, 10, here we have only 10 and 10. Did you see any pattern here? So if you basically add 5 to each of these numbers, you will get this exact part. Okay, so the difference between these and these is that only the initial value, which is 5, Here it is starting from 5, so it is 5 ahead. This part and this part has basically the same future. Okay, so the increment, the branches are almost exactly the same, just the initial difference is the difference it carry on. Okay, so you understand this by this thing, right? So let us say there is a staircase and a person starts from here, a person starts from the third step itself. Both move up with same speed. So which one would reach the top first? The person which is above, right? Because he has started, uh, he is great on the greater step and the speed is same. So the same thing applies here, right? Since this part is already ahead and they're moving the same pace, so this would already give always give me the bigger answer, right? Because this is always ahead, so there is no, at no point this would get ahead of this. Okay, so I do not need to uh, traverse this, because these both are similar and this is giving me bigger answer. So I don't need this part. So what I can do is actually ignore this part, not explore this part. So, as I said earlier, greedy does what? It eliminates our paths. So, this would actually reduce our total runtime, or decrease our time complexity. Okay. So, what I did here is that out of 5 and nothing, what I choose? I chose 5. So, I write here as new exclude my 5. That is why I said earlier, I took the maximum of this 5 and 0, because these 5 and 0 have had the same branches, and this basically gave me what, the part with same future. So basically the part which was ahead would always be ahead, so this 5 would always be ahead of this 0. That is why I wrote 5 here. Okay, now I hope you get the concept. So I will do this one more time, so you will get a complete understanding of how this actually works. Okay, now let us see. I get, uh, after including, I get what, 15. 10 plus 5 would be what, 15. Now here, for the exclude, I have again two options, here and here. So I would see the part above this cross. So this would give me, let us now take another color, this part, and what? This is the other exclude, right? So I would take this part. It is getting a bit messy, but you get the point, right? So now let us analyze again. Okay. This is 5, this is 10, this is 500, this is 10, 100, this is 5, this is 10, this is 5, 10, this is 10, 10, this is 5, this is 10, this is 500, this is 10, 100. Okay, this is 10 and this is 100. So again you can see this part is 5 ahead of this one, because we are starting 5 ahead. Okay, we are starting 5 ahead. So what we here, 10 is greater than 5, we are starting 5 ahead, which means that will always be 5 head, because these two trees have the same future. Okay, so finally this would give me bigger, greater answer than this one. So we don't need to analyze this part. Okay, so we can just ignore this part, and for now I can just remove it. So again we have decreased our total time taken. This is how greedy works again and again, by decreasing our path, by eliminating paths and decreasing our total run time. Okay, so you get the point, right? So here what I did was take the maximum of 5 and 10. So I got 5 and 10, I got 10. Here I wrote 10. And you can clearly see the next include is what? The next include is 10, 100. So I would get what? 110. And the same thing would happen again. Okay. So from further on, you can do this by yourself to get a clear understanding. Okay. For now, I'll just do what? I'll just use the formula. Okay. So I do the maximum of these and 2. This would give me 15. Now again, I would add 15 plus 5. This would give me 20. And this 115 give maximum would give me 110. So, so I hope you get the form. How did this formula actually come? So let us discuss for the including also. So you can clearly see, right? The including is what? The including is actually the current element plus the previous exclude. So you can verify this by doing this. 10 plus 0 gives me 10. 10 plus 5 gives me 15. 100 plus 10 gives me 110. 5 plus 15 gives me 20. So include is nothing but current element plus the exclude. Okay. So let us just code it quickly. Okay, so I want n is an integer input. Okay, now I want what? An array. Okay, inside this array I'm going to input my these n numbers. Okay, so for I in range, I should write I here. I would write what? 0. I don't need to write 0. Okay, I would just do array I array dot include, not include, it should be I can just use array dot insert. Here I would write I, or inside this I have to fill the current input, right? So this should be int input again. Okay, now that I have taken input, I can start analyzing, and you can clearly see, right, here we initialized our variables from 0 and 0, but the next step is what? The next step, include will always be the first element and exclude will always be 0. That is what we can do. We can save one step from iteration. We can just initialize a variable from include will start from what? Our first element, and exclude will start from 0. Okay, now I will iterate from 1 to n. Here I would write new include. A new include was what? This new include, here what I am updating, since I need previous values of include and exclude, I will make this new include and I will make this new exclude to actually store the previous values, right? Here I would make new include, and this would be array I plus the old exclude, which was basically exe. Here I would add new exclude. This would be the max of previous include and previous exclude. Now I would update the current include as new include and exclude as new exclude. And the last thing I want to do is actually print the max of what? As we saw here, our final answer would be max of include and exclude. Okay, max of include and exclude. Let us run it. We get a incorrect answer. Let us see what mistakes that we have made. Okay, this should be array 0, right? Not array I. Maybe we haven't done the indentation correct. Just a minute. Okay, this should actually be exclude I. So as you can see, we get the correct output here. Now let us submit it and verify our code. So you can see that our code is successfully running, and if you enjoy the video, like the video and share it, and I'll see you guys in the next video. Thank you.